Welcome back to the another episode of World of Physics. Now today in this session we are going to cover the second topic of the temperature measurement devices. Okay, so previously we have studied about the what is temperature measurement and how temperature is different from heat, and also we have discussed the RTD type of temperature, that is resistance temperature detectors. Now in this session we are going to discuss about another type of temperature measuring device, that is a thermocouple. All of you might be aware about a thermocouple junction, which you have studied in 11th and 12th science. Okay, a thermocouple consists of a wire of two dissimilar metals. Okay, two dissimilar metals are there which are welded at the ends to form two junctions. Okay, means this is material A and material B. They are welded at this one end. So this one end will be welded point will be one junction, and the other end, so the opposite end, this opposite end will be the second junction. As you can see in the figure, this material A and material B forms two junctions. Okay, so one junction is kept at a lower temperature and another junction is kept at a higher temperature. So two junctions at the junction at a higher temperature is known as a hot junction. Junction at a cold temperature is known as a cold junction. Okay, and by thermoelectric effect we can measure the temperature using this device. So what is a thermoelectric effect? The thermoelectric effect is the direct conversion of temperature difference to an electrical voltage. Okay, means this temperature difference delta T will result in voltage difference that is directly proportional. V is proportional to delta T, and on removal of proportionality sign, some alpha coefficient is there. The reverse is also possible. The voltage difference can give rise to the change in temperature. Okay, so vice versa is also possible. So thermoelectric devices create a voltage when there is a difference in temperature on each side. So that is the main idea behind this. And this thermocouple device is backed by three effects, namely Seebeck effect, Peltier effect, and Thomson effect. What is Seebeck effect? The Seebeck effect is that if different material are connected in two separate places and the intersection are kept at different temperature, means we are generating some thermocouples, one at a hot junction and another one at a cold junction. Okay, the meaning is that then a potential difference between the two junctions will result. So that effect will known as a Seebeck effect. What is Peltier effect? The Peltier effect is a phenomena that a potential difference applied across the thermocouple causes a temperature difference between the two junctions of the different material, means the vice versa portion, means Seebeck effect and Peltier effect combiningly forms the thermoelectric effect. Seebeck effect is nothing but Peltier effect is nothing but the opposite of Seebeck effect. Okay, next is the Thomson effect. So in different material the Seebeck coefficient is not constant in the temperature. Whatever the alpha we have seen, that Seebeck coefficient is not constant, and so a spatial gradient in temperature can result in a gradient in Seebeck coefficient. Means because of the change in temperature there will be change in a Seebeck coefficient. So if the current is driven through this gradient, there a continuous version of a Peltier effect will occur. So it describes the heating or cooling of a current carrying conductor with a temperature gradient. Means instead of using a large temperature difference, we are dividing that part for a small temperature difference, and for that small temperature difference the linearity will be obtained. So Thomson effect is nothing but a modified version of Seebeck effect for those materials where this temperature gradient is not constant. Okay, so let us discuss how a temperature is being measured by using a thermocouple. So thermocouple or the thermopiles are the device that uses the Seebeck effect to measure the temperature. What is thermocouple? As we have said, that junction that forms a hot junction formed by two different metals welded at the ends. Okay, so what are thermopiles? Thermopiles are nothing but a couple of thermocouples, means number of thermocouples connected in series, there are thermopiles. So they are used to measure temperature difference by using Seebeck effect. Okay, So as you can see in the figure, the unknown temperature source, that is hot temperature, is there, and at a reference temperature ice bath reference is there, means it is at 0 degree centigrade. Okay, ice bath means it is at where the ice is melting, means it is definitely 0 degree centigrade. As you can see, iron and constantan are the two different metals, they are used to form a weld. Okay, over here as you can see, these are the reference junction, and the copper wires are used to connect it with the voltmeter. So because of the difference in the temperature or the delta T, the proportional voltage will be generated in this voltmeter, and by measuring the voltage and calibrating it on a proper scale, we can measure the value of the thermocouple temperature of this unknown source by using these two thermocouples. Okay, the thermocouples are two junctions that forms a thermocouple. The thermocouples are often used to measure the high temperature, holding the temperature of one junction constant or measuring it independently, or that is cold junction. Thermopiles, as I told you earlier, uses many thermocouples electrically connected in series for a sensitive measurement of a very small temperature difference. Now the next is the thermistor. So thermistor is nothing but a modified version of RTD type sensors. Thermistor is a type of a resistor whose resistance is strongly dependent on the temperature. Okay, it is nothing but a type of a resistor whose temperature is dependent on temperature, more so than a standard resistor. The word is combination of thermal and resistors. The thermistor are widely used in rush current limiters, temperature sensors, where temperature sensors they are used as an NTC type, negative coefficient. Okay, or as self-resetting current protectors and self-regulating heating elements. They are known as the positive types. Okay, and operational temperature range of a thermistor is dependent on the probe type, and that is typically between -100 degrees centigrade and 300 degrees centigrade. Okay, as you can see over here, there is a plot of thermistor versus temperature, resistance versus temperature for a thermistor. As you can see, this is a curvilinear path, whereas in case of an RTD, the effect was a linear one. Okay, so what are the differences between the RTD, thermistor and thermocouple? As you can see, the temperature range for RTD is -260 to 850. For a thermocouple, the temperature range is -270 to 1800, and for thermistor it is -80 to 150 degrees centigrade. Sensor cost for RTD is quite moderate, for thermocouple it is quite high, and for thermistor it is quite low. System cost for RTD is moderate, for thermocouple is high, and for thermistor is moderate. Stability is best, low and moderate for respectively RTD, thermocouple and thermistor. Now comes the major important part, that is the sensitivity. Sensitivity is moderate for RTD, for low for thermocouple and best for thermistor. Whereas linearity, as we have discussed, RTD are linear, so linearity is best for RTD, moderate for thermocouple and poor for thermistor. As we have seen, the graph was declining. So specifically general purpose use for RTD, highest temperature can be measured using thermocouple, and whenever the best sensitivity is required, we can use thermistor. Okay, so these are the uses and the difference between the RTD, thermistor and thermocouple. Now let us focus on the another type of a device of measuring the temperature, that is a pyrometer. All of you might be aware about the temperature sensoring device nowadays that are being used in a pandemic situation, that we are using the temperature gun. Okay, whenever you go into the mall or some shopping center or some theater, they check the temperature without any physical contact. So that kind of device is known as a pyrometer. It works on a radiation theory. So when temperature being measured are very high and physical contact with the process or body is not possible, then in such situation non-contact type instruments are preferable. Nowadays, because of this pandemic situation, due to the transmission of contagious viruses, we are avoiding of direct physical contact. But before the COVID situation, this type of devices were also being used in the industry. So why and in which situation they are being used? So they are being used where there is a leak of radiation in nuclear power plant. There is a chances of a radiation leakage, And there are many instruments in industry, they are moving at a higher velocity. So in order to measure the temperature of that moving elements, we cannot put directly the sensor in that. Because of the motion, the sensors might get broken. So in that situation, this type pyrometry is used to measure the temperature without any physical contact. And nowadays we are extending that application to measure the temperature of a human body. So the technique for measuring the higher temperature without making any physical contact with the hot body then is called as a pyrometry. The pyrometer works on a principle of radiation heat transfer. It is the transfer of energy between the two bodies by means of electromagnetic waves. So we know that if there is some high temperature body kept over here, and if you just place your hand over it, if there is a vacuum in between these two, then you will also feel the heat. It's the same as that kind of a sun. The solar radiation comes to the earth, but still there is a vacuum in between them. The radiation transmits from higher temperature to lower temperature because of the radiation heat transfer. We will study this type in detail, and the laws regarding this radiation heat transfer are the Stephen-Boltzmann's law. You might be aware about the Stephen-Boltzmann constant. Okay, so these are the governing principles behind the heat transfer by radiation mode, and using that fundamentals and using that principles, we are going to detect the temperature by this radiation pyrometer. Okay. So one such example of radiation pyrometer, as you can see in the figure, is the radiation pyrometer. In this, the object whose temperature is to be measured is kept over here. As you can see in the figure, the radiation coming from that is directly allowed in front of the instrument. Inside the instrument, what is the construction? There is one detector disc, as you can see over here. Because this radiation directly don't affect on this detector disc, we are using a shielding element. But from the rest of the part, this radiation can enter and get reflected from this concave mirror, and they are focused to this detector disc, as you can see on the figure. So because of this focus of this radiation, the temperature of this disc will get raised, and it is further connected to this thermocouple. It forms a junction, as you can see, where there is one cold reference, and this detector disc is connected to a hot reference, and hot junction forms this detector disc, and this is the cold junction, and by using the suitable voltmeter we can just get the temperature difference. Or else by observing the changing color of this disc using this eyepiece through this hole, we can just say the temperature. As you can see that using the pH paper, the changing color, you can give the indicator that this will be the pH value of that. So by changing the color, you know that this is the pH value. Same thing happens by changing the color of this disc. You can define the temperature value of this object by using this radiation pyrometer. So two methods are there. Nowadays we are using the electrical method, that is quite best suitable and less time consuming. Okay, so on the digital display you can directly see the whatever the temperature is there. Another one is optical pyrometers. In optical pyrometer, this this mirror is now replaced by this objective lens. As you can see, the temperature object whose temperature is to be measured is there. It is all the radiation coming from this object are now focused using this objective lens on this detector. Okay, so this lamp filament is now a detector. Okay, so you can change, you can observe the color, or you can directly connect it with the RTD type sensor, and by measuring the voltage or current, you can just get the value of this temperature of this object. So this was all about the optical pyrometer, and that's it for today, guys. This was all about the temperature measurement topic. So that's it for today, guys. Thanks for watching.